Samples of sodium ion, potassium ion, calcium ion, copper 2 ion, and zinc ion were prepared. Pour concentrated hydrochloric acid into a beaker. Prepare a flame test rod. Clean the flame test rod by putting it into concentrated hydrochloric acid and heat it with Bunsen flame. Make sure that there is no characteristic flame color. Obtain the sample at the tip of the flame test rod and heat it with Bunsen flame. Sodium ion gives a golden yellow flame. Potassium ion gives a lilac flame. Calcium ion gives a brick red flame. Copper 2 ion gives a bluish green flame. Zinc ion doesn't give any characteristic flame color. Therefore, it shows a negative result. Aqueous solutions of magnesium ion, aluminum ion, zinc ion, and lead 2 ion are prepared. To each of the sample, add a few drops of dilute sodium hydroxide solution. Observe the resulting solution and see whether precipitate has formed. If you are not sure about whether precipitate has formed or not, you can compare it with tap water. White precipitate is formed in all 4 samples. Add excess amount of dilute sodium hydroxide solution in all 4 samples and see whether the white precipitate will dissolve. It is observed that the white precipitate with aluminum ions has dissolved. To further investigate, transfer small proportion of the reaction mixture into new test tubes and add dilute sodium hydroxide solutions. It is now observed that the white precipitate in both lead ion and zinc ion has dissolved in excess dilute sodium hydroxide solution. On the other hand, the white precipitate with magnesium ion remain undissolved. Aqueous solutions of magnesium ions, aluminum ions, zinc ion, copper 2 ion, and silver ion are prepared. Add a few drops of ammonia solution into each sample. White precipitate is formed in the presence of magnesium ion, aluminum ion, and zinc ion. Blue precipitate is observed in the presence of copper 2 ion, and brown precipitate is observed in the presence of silver 1 ion. Excess ammonia solution is added into each sample. White precipitate with magnesium ion and aluminum ion remain undissolved. White precipitate with zinc ion redissolved. Blue precipitate with copper 2 ion redissolved, and it forms a deep blue solution. And lastly, the brown precipitate with silver 1 ion has redissolved to form a colorless solution. Transfer ammonium chloride solid into a test tube. Add dilute sodium hydroxide solution into the test tube. Heat the reaction mixture and place a moist red litmus paper near the mouth of the test tube. The litmus paper changes from red to blue. You can also place a bottle of concentrated hydrochloric acid next to the mouth of the test tube. White film is observed. Pour lime water into a test tube. Place a delivery tubing into a test tube containing lime water. Pour hydrochloric acid into a test tube. Check whether the rubber bung of the delivery tubing can fit into the test tube containing dilute hydrochloric acid. Transfer the sample containing carbonate into a test tube with dilute hydrochloric acid. Connect the delivery tubing. Drop the carbonate into the hydrochloric acid. Bubbling occurs in the hydrochloric acid and the lime water turns milky. Aqueous solutions of sulfide ion, sulfate ion, and carbonate ion are prepared. Add a few drops of barium chloride solution into each sample. White precipitate are observed in all three samples. Hydrochloric acid is added to distinguish between one another. Bubbling is observed when hydrochloric acid is added into a sample containing carbonate. Add dilute hydrochloric acid into a sample containing sulfite ion and place a moist blue litmus paper near the mouth of the test tube. The gas produced will change the moist blue litmus paper from blue to red. Similar procedure was repeated with sulfate ion, and the moist blue litmus paper doesn't show a color change. Aqueous solutions containing chloride, bromide, and iodide are prepared. A few drops of silver nitrate solution were added into the samples. The solution containing chloride gives a white precipitate. The solution containing bromide gives a creamy precipitate, while the solution with iodide gives a pale yellow precipitate. It is quite difficult to distinguish between the colors of the three precipitate. Therefore, ammonia solution was added into the sample to further confirm the identity of the ions. Upon adding ammonia solution, the white precipitate with chloride redissolved. The creamy precipitate with bromide redissolved upon heating. Even with heating, the pale yellow precipitate with iodide remained undissolved. Aqueous sample of chloride, bromide, iodide are prepared. A few drops of chlorine water were added into the samples. The solutions containing bromine and iodide change from colorless to pale brown. To distinguish between the two solutions, hexane was added. The bromine, which comes from the bromine ion, appears orange in the hexane layer. The iodine, which comes from iodine ion, appears purple in the hexane layer. Solid sample containing chloride, bromide, and iodide are prepared. A few drops of concentrated sulfuric acid was added into the samples. Orange vapor of bromine and purple vapor of iodine are observed. Hexane was added as a confirmatory test. Bromine dissolved in hexane layer to give an orange color, while iodine dissolved in hexane layer to give a purple color. Solid sample containing hydroxide ion is prepared. Add dilute ammonium chloride solution into the solid. Heat the reaction mixture and place a moist red litmus paper next to the mouth of the test tube. The red litmus paper changes from red to blue. Place a bottle of concentrated hydrochloric acid next to the mouth of the test tube. Dense white fume is observed.